Hey, what's up guys? It's Nicola from Calcunic, and today we're going to be proving that 0.99999 is equal to 1. Let's get right into it. Okay, in today's video, we'll be answering the question, does 0.99999 equal 1? And before we start, let's just get some syntax out of the way. This upper bar here just signifies that this is equal to 0.999. The bar just means that that particular digit goes on into infinity. And so when I explain this to my friends, they usually say, no, Nicola, that's impossible. 0.9999 just can't equal 1, right? It's always going to be off by a little bit. It'll never actually equal 1. And I'll say, well, guys, we have that 1/3 is equal to 0.3 going on into infinitely. And if you multiply both sides by 3, we get that 3/3 is equal to 0.99999, and 3/3 is just 1, right? So 1 equals 0.9. But they'll still say, no, that just doesn't feel right. I don't feel convinced, right? And so in this video, I brought together 3 of my favorite proofs showing why 0.9999 equals 1.
Apart from the one that I've just shown.
At the end of the video, let me know which one is your favorite. Okay, so our first proof is probably going to be the easiest out of the 3, and is actually my personal favorite as well. So how we start is by saying that x is equal to, let x equal to 0.999. And you'll see in a second why we're going to write all these out. It's going to be for some clarification purposes. And what we're going to do is multiply both sides of the equation by 10. Okay, so we're going to have 10x on the top. And on the right hand side, just the bottom times 10, we're going to have 9.999. And the trick here is going to be subtracting both equations by itself. So let's see how that's going to look. Well, on the left hand side, we have 10x minus x. That's just 9x. And it's equal to what? Well, the right hand side has 9.9999 minus 0.99999. And we see here that the 9's actually just cancel themselves out in subtraction, and so will all the infinite 9's that go after that, and all we're left with is 9 minus 0, which obviously is just 9. So we have 9x equals 9, and well, divide both sides by 9, we get that x is equal to 1. And remember from before, we defined x is equal to 0.99999. We're going to bring that fact down here, just right there, equals 0.9 going on into infinity, and there is our first proof. 1 equals 0.99999. So let's start our second proof, and this proof will be a bit more philosophical than mathematical, but nonetheless rigorous mathematically. So we'll start off by writing, let's take two numbers x and y, and we'll draw a little number line for them, and we'll have x is here and y is here. And so we'll make the observation that if we could find a number, call it z, in between x and y, then it must follow that x and y are then not the same number. Right? Because if two numbers are different, then you'll be able to find a number in between them. That's just common logic. And if x and y are the same number, you will not be able to find a z in between them. So let's use this logic to show why 0.9999 equals 1. So we have 0.99999, and we have 1. And so let's draw our number line as we did before for x and y. And here we'll have 0.9, and here we'll have 1. So let's ask ourselves, can we find a z in between these two numbers? And the answer is no. Because 0.99999 gets infinitely close to 1, you actually can't find any z that's going to be in between these two numbers. And by that logic, since we can't find a number in between those two, they must be equal. So therefore, we conclude that 0.9999 is equal to 1 in fact. This is going to be our third and final proof method, and is probably the most difficult and most mathematically rigorous. So first, what we're going to do is express this number in the form of a series. So we have that 0.9999 is equal to 0.9 plus 0.09 plus 0.009, and you get the picture going on forever. Now what we're going to do here is express this in summation notation. So we have that the sum from k equals 1 to infinity of 9 times 1 over 10 to the k. And a quick check will show us that this is in fact the summation that represents this series. If we input k equals 1, we get 9 over 10 or 0.9. K equals 2 gives us 0.09, and so on and so forth. Now looking at the series, we'll notice that this is in fact a geometric series because each term is 1/10 of the previous. If you don't know what a geometric series is, don't worry, I've added a link to one of my previous videos that describes it pretty well, at least in my opinion. What we want to do with this information is to use the formula for the sum of an infinite geometric series, which is defined as follows. We have that the sum from n equals 0 to infinity of a times r to the n is equal to a over 1 minus r when the absolute value of r is less than 1. If we compare the expression we're given and the expression for a geometric series, we see that they're pretty similar. We have that a is 9, and in this case r is equal to 1/10, and because the absolute value of 1 over 10 is less than 1, we can represent the summation using this formula. However, there's a small difference. Here we have the counter starting at k equals 1, and here we start at n equals 0. So we're going to have to make a small adjustment and change the counter on the initial summation. To do this, we'll simply subtract what we would have added by changing the counter down to 0. We see that the difference in between these two formulas is that this summation has an extra term when k equals 0. And when k is 0, 9 times 1 over 10 to the 0 is equal to 9 times 1, or just 9. So therefore, we're going to subtract by 9 to make sure that this equality holds. Now, all that we have to do is to input the formula, and we get that this is equal to 9, which is a, over 1 minus 1 over 10, and all minus 9. Doing some reducing, we get that this is 9 over 9 over 10 minus 9. This is equal to 10 minus 9 because the 9's cancel out. And finally, this is equal to 1. And we see we started with 0.99999 and ended with 1. So therefore, we could conclude that 0.9 does in fact equal 1.
Alright guys, thank you so much for watching. Like I said before, comment down below which of the 3 proof methods you like the most. And also if you had any questions, concerns, or other video suggestions, leave those too and I'll try to get to them. If you like what you saw, or if you feel like you learned something today, please leave a like and subscribe. It's not much, but it really helped me grow my channel. That's all from me. Till next time.